So, you said you had a question. Yes, what are free radicals? Excellent question. To answer that, I need you to go to a drugstore and get some hydrogen peroxide. What? H2O2, the disinfectant. Ah, okay. But it is freezing outside. Do you want the answer to a question? Yes, for sure. I'll be right back. Okay, quick run to Shoppers Drug Mart. So you are back. Yes, here's the hydrogen peroxide you asked for. Perfect. Now we are ready to learn about free radicals. Come here, I will show you some examples. All free radicals start with oxygen. Elements create bonds between each other when they form larger molecules. Oxygen always requires two bonds. That is why pure oxygen molecules come in pairs, O2. Another well-known example is water. In H2O, one oxygen atom creates two bonds with two hydrogen atoms. Are you good so far? For sure, every kid knows such things. Good, let's keep going. Now imagine the stable water molecule loses one of the hydrogens. Oh no, now oxygen is missing one bond out of required two. The name of this new molecule is Hydroxyl Radical. What do you think it will do? Will it go looking for something to grab onto? Bingo! And not just go, but will rush with radical attitude. Interesting. Yes, free radicals do not stop until they find their prey. Like hyenas, they attack peaceful molecules and bite pieces out of their bodies. Oh no! For example, it can attack DNA and destroy some of its genes. This can lead to cancer. Uh-oh. Free radicals can attack and damage anything and everything in our body. This process is called oxidative stress. Bad stuff. Wrinkles on our faces are one of the examples of such a process. However, most of the damage happens inside of our bodies, unseen to us. Sounds scary. For example, let's take a closer look at our cell membrane, which is made of fatty acids. When a free radical attacks it, it finds the weakest spot of the peaceful molecule and bites the hydrogen atom of it. The hydroxyl radical is now complete and satisfied. The second bond has been created and it turns into water. It is happy now. However, we have a problem now. Our fatty acid molecule has a hole in its body. It is missing one bond, which is a big no-no. So it turns into a radical itself. If there is oxygen nearby, it is happy to join the party. It attaches itself to the fatty acid. However, now we're back to square one, as one of the new oxygens does not have the required second bond. So this new molecule is still a radical. Most often it attacks its neighbor, another peaceful fatty acid, and steals a hydrogen atom from it. The newly created creature is no more good for the cell membrane. It rapidly disintegrates into toxic substances. They go all over our bodies and deal lots of damage. And the neighbor molecule that is now missing one of the hydrogens goes through the exactly same process. The cycle repeats, and more damage is created. And this is just one of the many examples of how free radicals damage our bodies. Wow, this is scary stuff. Yes, oxidative stress kills. For us humans, it takes years. But for smaller bacteria, it's like instant death. Wait, bacteria! That is why you wanted me to get the hydrogen peroxide. Yes, it is an excellent illustration of the deadliness of free radicals. Interesting fact, H2O2 destroys microorganisms 5,000 times faster compared to chlorine, which we use for cleaning our drinking water and pools. Hydrogen peroxide is a very unstable molecule. The bond between two oxygens is very weak and can be easily broken down by light. That is why it is stored in non-transparent containers. And once the bond broken, what are we left with? Oh, those are two free radicals. Correct! Hydrogen peroxide breaks down into two hydroxyl radicals. If there is nothing around to attack, they bite into each other. Hydrogens are stolen and water and oxygen are created. However, if there are bacteria around, those free radicals attack and destroy their cell walls. Just as we saw in the previous example with fatty acids. As a result, bacteria disintegrate and die. Aha! This is how we disinfect wounds. Yeah, we do. But here's the problem. As much as we damage the bacteria, we damage our own tissue. Yikes. However, our body is very familiar with H2O2. It is regularly produced as a byproduct of our daily metabolism. What? Do not worry, we have a special enzyme called catalase that neutralizes this hydrogen peroxide into water and oxygen. Just one catalase molecule can process about 1 million hydrogen peroxides per second. In the process, lots and lots of oxygen is created, hence you see all those bubbles. Oh, this is cool! Yes, and we will demonstrate it with the hydrogen peroxide that you brought. Let's go. All organisms that use oxygen have catalase enzyme in their cells. For our experiment we will use yeast, which also has catalase. Yeast? Interesting. Yes, by mixing yeast and H2O2 we will create a lot of oxygen. And we will trap it with a dish soap, which should give us some nice foam. And for nicer effect we will color it with some food coloring. Should look nice. And as a bonus I have a professional solution of hydrogen peroxide. The one that you purchase at the store is a 3% solution, and this one is 12 times stronger. Let's see if it gives us a better foam. Okay, let's do it. Did I answer your question? Yes, now I know what free radicals are. They are dangerous molecules that are missing one of their bonds, so they attack a nearby tissue and damage it. Good job! Yes, free radicals kill our bodies, but luckily we have some protection against them. Phew! Not so fast. The problem is that the modern nutrition and lifestyle greatly overwhelm us with the free radicals. There are just too much of them. Oh no! Yes, and our protective system cannot neutralize all of them. There are just too many of them. So inevitable damage occurs. So where do those extra free radicals come from? To hear that story, you would have to come back next week. Okay, sounds good. I will be back next week. Thank you.